Yeah, there is stuff online. So if you have a phone or a laptop, you should be able to get to the practical stuff online. So there is, we've suggested an ebook textbook which is available through the library, and there's a bit of information, not perfect, in White's textbook, which you can have a look at. So that's described in the unit outline. You can get to it easily through one search, right? Few notices today. There's a few bits and pieces from the field trip that we probably need to catch up with, right? So some of you didn't or couldn't sieve your soils in the field because they were too wet. Now you'll go in groups, I believe, with Louise or Kirsty down to the drying room, which is at the other end of the building. If only to check your soils to see if they're dry enough and make sure that they're correctly labelled, that everybody in the group's sample has arrived safely in the drying room. Some of them will need sieving, and I believe that some people didn't get to make all the measurements that they would have liked to in the field, like pH and EC and measuring colour and things. So there's some gear set up in Lab D, that's the one behind us, to enable you to do that sometime today. So the rest of today's exercise is more of a thinking, calculating, pen and paper exercise, and I'll go through some of the theory behind it now. So what we're talking about is the process of mainly chemical weathering today, where an unweathered rock alters in some way. It reacts with its atmosphere and the fluids around it to form different weathering products. And those weathering products include just broken up material, and that's quite important for the properties of soil and regolith that we find out. But importantly for today, we end up also with some secondary minerals, some minerals which have changed chemical composition to those which were present in the original rock, and we actually lose some stuff as well. And some chemical elements are lost more than others, and that becomes important when we try to understand and actually measure, put numbers to the weathering process, and you're going to do some of that today. Right, so one of the things that we will look at, and some people actually saw this in the field quite nicely, is that we can use the progress of weathering in some instances to actually date soils. Now, what I want you to do in the prac with this type of information is to think about what would make these types of measurements valid. So here's a clue for you. Different rocks weather at different rates. So the time dependence of the thickness of the weathering rind will differ depending on what type of rock we've got. So that's one type of thing that we would need to consider in terms of using weathering rind thickness. So that's the altered skin around the fresh rock, which you can see in all of these diagrams, and they've got ages. And there's an example of this probably shown a bit better in your lab manual. Okay, so that's one thing we'll have a look at, but that's more qualitative, I guess. The other thing that we can do is to use analyses of rock and soil materials to estimate a weathering index, so we can get some number that we can put on the intensity of weathering. And this is based on a couple of features of the weathering process, in that some elements like aluminium and iron tend to stay in soils, and we saw that on the field trip. We saw a lot, for example, of iron oxide rich gravels which remained in the soils, and what we know happens to some of the other elements like sodium and calcium and potassium, they form compounds with much higher solubility, so they tend to be lost with the water that runs through and across that landscape into rivers, and they form part of the salinity in oceans, right? So that's part of the weathering process, and because of that, we can use the elemental composition of our rock or soil material to calculate weathering indices. For example, one of them is called the chemical index of alteration. I kind of like it because I like spy movies, and it's called CIA. For no other reason than that, but it's a useful index because you can use the concentrations that you would typically analyze in a rock or soil material of aluminium, often expressed as the oxide, or Al2O3, and calcium, sodium, and potassium to calculate the CIA index. All right. So if sodium and potassium and calcium tend to get lost, is that index going to increase or decrease as a rock gets more weathered? Increase, exactly right, because these the denominator will become smaller, Okay, so the fraction will come closer and closer to 1. So our value will approach 100% for a completely weathered material, but it won't be 0 for an unweathered rock, because the unweathered rock will contain all of these components. The starting point will depend on the rock type. So you will do something like this, and I've got a data set for you, which you can see in your lab manual on page 8, and those data are available as an Excel file on LMS. And what I would hope you would do would be to calculate the CIA, or chemical index of alteration value, as a function of depth. And the data that you have come from deep regolith material, similar to what was under our field site, but in this case it was from a different part of the Darling Plateau. Right, now there's just one trick with the calculation, in that these concentrations in the CIA equation are not just normal weight percents. They should strictly be mole percents, which is why when you open the spreadsheet on LMS, you'll find that we've also included the formula weights for each oxide. You don't even have to calculate themselves. We're that kind to you. All right, so we need to correct for the molar weight of each oxide, and I guess we calculate a mole fraction, if you like, and we can talk you through that if you need talking through it. All right. So there's some examples of unweathered rock materials. Basalt tends to have a starting CIA value of around 35, granite around 45 to 50, and shales, which are sedimentary rocks, they've already been through one cycle of weathering, they tend to start at a higher value. All right, so you're going to do one of those calculations as part of this prac. Just a reminder, this prac and some of the other lecture material that you will have done will form part of the quiz, which is becoming live when, Louise? This Friday? Yeah. Okay. So there's the incentive for actually doing the work, because some of the questions will be directly based on the prac material. Not that you, of course, needed an incentive. Okay. Just a note about the CIA values. Sometimes we see a progressive increase in CIA values with depth, but sometimes not. In some regolith materials, there might be younger stuff which has been deposited on the top and changed our depth profile of the CIA parameter. So we can start to understand things like that, discontinuities in the record as well, using that type of index. So just put this in context, we've got highly weathered soils all over the Australian continent, but probably nowhere as abundant as southwestern Western Australia. So most of the Yilgarn Craton, this geologically stable area of very ancient rocks, is one of the most intensely weathered environments on Earth. So you guys ought to understand weathering if you're going to work in soils, environmental science, agriculture, whatever. If we look at the distribution of weathering features like Fairy Creeks, you can see in the map on the right-hand side there of southwestern Western Australia, the Darling Plateau is pretty rich in these sort of features as well, the accumulation of iron and other elements in Fairy Creeks. Okay, and this is all related to the lateritic profile, which I believe Matthias will go through with you, or has done already, where we see a typical intact profile having topsoil, sandy at the top, duricrust, which is our iron-rich accumulation, over a quite depleted zone. This is where our elements are lost from, in what we call the mottled and pallid zones, over rock of varying freshness of weathering. And that's another question you'll need to think about. Is the rock at the bottom of the profile, that with the data that we've given you, is it very fresh, or is it being weathered a little bit already? Okay, I'll flick through that. There's some references and stuff at the end of the presentation. I'll upload this to LMS after today, and that's probably about all we need.